Yo, welcome back to the non-live stream. It's part two. I didn't introduce myself last time, but my name is Dr. James Utley. I'm your resident codebreaker data scraper, and here I'm building Goomol VisEngin. So that's Gumol, which is a GPU accelerated version of Gumol, which is a molecular dynamics engine. Then this is the visualization engine. So you do the simulations in Gumol. Then you bring it over to the visualization engine, which is Goomol VisEngin. I built it all in Rust, and I use this game engine, or this game framework, game engine, called Bevy. So Bevy is a game engine used for Rust development, and it uses a system called the ECS, Entity, Component, and System. I should really look that up, because I say system every time, and I'm not sure that's what it stands for, but I'm like sort of sure. All right, well, here we are. So, in the last episode of the non-live stream, we were like messing around with spawning, using the GPU more efficiently, etc., etc. And now I think we're at a spot where we should do some testing. I don't know what you think. So, here we are. So this is like a combo. These are the so I do some, of course, Rust development, and you have to know Rust to develop in Rust with AI agents, because AI agents know like 80% Rust, and then like 20% they just really suck. So you just need to know like how to read the code and fix the code, which is great. But I use this agent workup, which is this cursor model called Composer 1.5, which is legit. And for one is, if you're a cursor member of some sort, then you get that you get this model like included. And for me, I don't need the latest and greatest model to do everything, because I just need you to do some of the, I just need the models to do like the mundane work, which is like just building the frameworks to the functions and some different traits and just shit like that, and like being able to fix like this ownership continuum that's in Rust, and so you're not like biting the borrow checker so much. But anyway, it's like good enough, it's like an assistant that knows enough to, like you're the surgeon and the assistant does all the grunt work, and then you just pick it up and do the precision. Anyway, maybe that's a bad analogy, but yeah, so I use this Composer 1.5 model, which is like real general purpose. So this is not oriented towards Rust at all. So with that, is I have to use, I have to use this other engine, which is called Vybrid. So Vybrid is a agentic coding tool that I repurposed from DeepSeek Engineer Volume 2 or version 2, and then I just busted it all apart and made it a Rust coding agent built in Rust for Rust development. And it is pretty legit, meaning like, so if you have Composer 1.5 here in your cursor browser, like I'm pointing at right here, like that can set like a base layer. Then you need something that's a little more Rust forwarding, or like more specifics in Rust, or have the ability to code a little better in Rust. Then I use Vybrid, and that kind of like, and then you bring in the superhuman, which is this brain to fix it all up. Because if you try like end to end with any model, like it coding something in Rust, like it ain't gonna get you far, man. There's some features about Rust that I feel that can benefit an end state in agentic coding or agent code gen. Definitely not vibe coding. So you can't even call it that, because there's no vibes. The vibe you have is anger because of the borrow checker, because of the compiler. So, but what I'm saying is that if you use Rust, because it has all these safety checks, you have to do the code right the first time so it compiles correctly and all of that stuff. AI doesn't have the ability to kind of iteratively loop with Rust, because it's like you build something and then you're gonna use the compiler here. It's gonna take some time to compile. If there's an error, then you gotta like hit this loop again and again and again. And it just loses. At some point, it's good for like a couple of iterations. It loses context, moves into the doom shot land, where you just can't keep up. So that's where it's shitty for developing Rust. But if you have projects as an engineer built up, you can have it build one little section. You can then have it build another little section, and then you got to like kind of merge it all together. Like that is the best way for Rust development. And by doing that, you just have to, like as an AI engineer, you have to like know the tools to select. But anyway, now I'm just like ranting. Okay, but anyway, I use this coding agent Vybrid, which is Rust heavy, and then Composer 1.5, which I call Rust Lite, but it just, just knows basic stuff. All right, so but anyway, I'm not going to use that now because we're done. What I am going to do is I'm going to try to do some testing of this VisEngin with the PDB file. So it's going to do a little compiling and building. We got some warnings. Don't worry, warnings. I'll get rid of them. I hate warnings, but you can just, if you want to hide them away, you can hide them away, but they feel like dirty laundry to me, so I always go through and clear them out. But while that is cooking, I need to go look at, see what you're looking at. Okay, yeah, still looking there, and we'll let this thing compile. But as you see, now we have two windows, from my view, that I'm going to need to change. Okay, so now you see this is all burning. This is all burning quite efficiently. Well, the question is it efficient? Well, that is a good question because I'm seeing it over here in this other window, which I'll just show you briefly. Or maybe we'll let me. That we might be like stressing the GPU here. Alright, let's undo. Oh, I didn't know that was a feature, but I just learned another feature. Okay. Alright, so we're cruising there. It's gonna go a little black. Then we're gonna get over here. So now you should be seeing like where this is that PDB file, and this is everything that's with the engine. But if you remember that we still have some latency, which means that you cannot move this. It's kind of stuck here in time because it is stressing. Which, let me set us back to here. It looks like there's a bunch of spawning going on, and the latency continues. Well, let's do a little check here. Okay, so let me show you what's happening also again. Open the selector here. I'm going to show you this. If you see this, hopefully there's nothing sensitive here. No, well, you see the GPU is not working as fast as it should. Like we should get more. Should get more usage of it. Anyway, there's some problem. Always a problem. But we'll fix it. So I think you're gonna stay optimistic. All right, so let's get us back here. Let's close out some of these little windows. Let's close this. Okay, so it got the command to close the window, but did it close the window is the question. Hell no it didn't. It's like hung up. So we're just gonna kill the program. Okay, and we did. So let's do it. All right, let's do it a little differently then. Let's just go straight up. Oh, okay, so all right, now let's see what you can see. Okay, let's change this to. Let's change it to the. All right, we have a smaller molecule here. All right, so you see. Scanning in, scanning out, we got this, which is just a demo. It's a demo file that I built. Alright, so we're good there. Now, let's just try to look and see if we get... Okay, so now we have this 1CRV PDB file, and we have what is this? Okay, so we're going to need a way to be able to control the space. Let's change back up. Okay. Yeah, bro, this is crazy. Alright, let's try this dialogue. See where we're at. Yeah, we're going to have to build a way to like see these things. Because I'm not sure. I'm not exactly sure what's happening right now. Like, what am I supposed to be looking at? This definitely is not it though. Okay, so I know that I have something here, which is 1,198 atoms at one frame. Okay, I see that there is a lot of, it's like 10 mons per second, but I'm not sure. Single frame trajectory. Alright, well, they're killing it. Sorry, my guy. You are getting killed. I'm not sure. Yeah. Yeah, so let's see, we back it up here. Take a look. It looks like it's spawning 10 bonds at a time, 1,198 atom, but for some reason it should be actually a lot more than that. So there's definitely a problem. Now, let's see. All right, we're 16 minutes in. All right, thanks for joining my second non-land stream. Be it for today. I'm gonna continue to work on this. We're gonna get this VisEngin up and running, but we might take a break and go work on Gumol specifically. Aperture for GPU accelerated.
Molecular dynamics, rust, and until next